Hello, I am recording the video and today's topic is multi-threading. A thread is defined as the execution path of a program. Each thread defines a unique flow of control. If your application involves complicated and time-consuming operations such as database access or some intense input-output operations, then it is often helpful to set different execution paths or threads, with each thread performing a particular job. Threads are lightweight process. One common example of use of thread is implementation of concurrent programming by modern operating system. Use of threads saves wastage of CPU cycle and increase efficiency of an application. So far, we compiled programs where a single thread runs as a single process, which is the running instance of the application. However, this way the application can perform one job at a time. To make it execute multiple tasks at a time, it could be divided into smaller threads. In .NET, the threading is handled through the system.threading namespace. Creating a variable of the system.threading.thread type allow you to create a new thread to start working with. It allows you to create and access individual thread in a program. Thread life cycle. The life cycle of a thread starts when an object of the system.threading.thread class is created and ends when the thread is terminated or completes execution. Following are the various states in the life cycle of a thread. The unstarted state. It is the situation when the instance of the thread is created but the start method is not called. The ready state. It is the situation when the thread is ready to execute and waiting CPU cycle. The not runnable state. A thread is not runnable when sleep method has been called, wait method has been called, blocked by input output operations. The dead state. It is the situation when the thread has completed execution or has been aborted. Thread priority. The priority property of the thread class specifies the priority of one thread with respect to other. The .NET runtime selects the ready thread with the highest priority. The priorities could be categorized as above normal, below normal, highest, lowest, normal. Once a thread is created, its priority is set using the priority property of the thread class. Observe the following. When the page is loaded, a new thread is started with the reference of the method child thread call. The main thread activities are displayed directly on the web page. The second thread runs and sends message to the label. This article explains how multi-threading works. You will learn how the operating system manages thread execution and shows you how to manipulate the thread class in your program. To create and start manage threads. This article covers the entire range of threading areas from thread creation, race conditions, deadlocks, monitors, mutexes, synchronization and semaphore and so on. Multi-threading overview. A thread is an independent stream of instruction in a program. A thread is similar to a sequential program. However, the thread itself is not a program. Cannot run on its own. Instead, it runs within a program context. The real usage of a thread is not about a single sequential thread, but rather using multiple threads in a single program. Multiple threads running at the same time and performing various tasks is referred as multi-threading. A thread is considered to be lightweight process because it runs within the context of a program and takes advantage of resource allocated for that program. With the task manager, you can turn on the thread column and see the process and the number of threads for every process. Here you can notice that only cmd.exe has a single thread, whereas all other applications use multiple threads. The operating system schedules threads. A has a priority and every thread has its own stack, but the memory for the program code and heap are shared among all threads of a single process. A process consists of one or more threads of execution. A process always consists of at least one thread called the primary thread or a main method in a C programs. A single threaded process contains only one thread, while a multi-threading process contains more than one thread for execution. On a computer, the operating system load and start applications. Each application or service runs as a separate process on the machine. Background thread. The process of the application keep running as long as at least one foreground thread is running. If more than one foreground thread is running and the main method ends, the process of the application keeps active until all foreground threads finish their work. And by foreground thread termination, all background threads will terminate immediately. When you create a thread with the thread class, you can define it as being either a foreground or background thread by setting the property is background. The main method sets the property of the thread T to false. After setting the new thread, the main thread just writes to the console and end message. The new thread writes a start and an end message, and in between it sleeps for 2 seconds. Concurrency issue. When starting multiple threads that access the same data, your program needs to ensure that any piece of shared data is protected against the possibility of numerous threads chaining its value. Deadlock. Having too much locking in an application can get your application into trouble. In a deadlock, at least two threads wait for each other to release a lock. As both threads wait for each other, a deadlock situation occurs and threads waits endlessly and the program stops responding. Thank you.